Mhm.
So, how are your fast going on? Are they going good?
Going good. It's going good.
So, we have started with unit 4 yesterday. That was unit 4 in that chapter 5. And that we have seen the definition of probability. So, the mathematical calculation, the mathematical interpretation of calculations, interpretation of chances is known as probability, is known as probability, and is known as probability. And we have seen the formula for probability. I have told you to remember a formula every time you do probability, simple probability, you remember this formula: probability of any event, you say, of any event means any task you want to do and an experiment. Okay, so is equals to number of favorable outcomes, number of favorable favorable outcomes divided by the total number of the total number of outcomes. That is the thing. That is the formula for probability. This all we have seen. Then we have seen what is randomness. Randomness, why randomness is important. So we have discussed a long, huge part yesterday. What is randomness and why it is important, and you have seen randomness of a large sample space. Randomness of a large sample space, or you can say large sample size, it tends to better assumed result, better assumed result. And just for a recap, we have seen that while tossing coin, till you get head, till you get first head, first head, or you can say it can be termed as not taking this as for now, because this comes into one distribution that known as negative binomial. Or you can say tossing a coin thousand times, and and noting head head count, how much times head comes in the toss of 1,000. So you know that as the probability of head when a coin is tossed is half, 0.5. This is calculative, correct? Calculative. But when we generally do an experiment, so in the probability of head in 1,000 times, there was total number of tosses were 1,000, and it will come near about, for suppose 492, so it is around 4.92. So the larger the sample size, the closer will be the value of the probability. It can come 4.92, or it may happen, it may come as, but it will be very close to 0.5. As larger the sample size, it will run close to 0 point, sorry, it is 0 point, sorry.
Mhm.
0.492 and it is 0.55. So it is close to 5. Is it clear? That was the thing we have seen with the case with randomness. Okay. So random process and probability. So we will start with random process. What is a random process? We have generally seen multiple definitions with regarding a single, what you will say, single word, but the things differ is that it occurs in different chapter and with what you will say, different task, what we are doing there. So a random process generates outcomes that are determined purely by chance. Means what is a process? The process that we are taking, that is random. So this is a process. This is a process which is, I'll write the definition as which is purely based on chance. Based on chance means there is no biasness. Means there is no biasness on the outcomes. For example, I am tossing a coin, so coming off heads and tails have equal chances. So that's the thing. It is random that it may come head, it may come tail. The process is random process. Why? Because purely chance based is there. Whether it will come head or whether it will come tail on the upper face, on upper face. That is the thing. So, okay, so generates outcomes that are determined purely by chance. So, what is probability? The probability of any outcome. So, in this random process, in random process, the probability of any outcome always lies between 0 and 1. Means it cannot cross the, this is the what you say, lower limit,
Mhm.
and for example this is the upper limit. Cannot
Mhm.
go beyond 1 and it cannot go below 0 as well. Okay, so that's
Mhm.
the thing that describes the proportion of times the outcome. So what he's defining the probability, the proportion of time the outcome would occur in a very long series of trials. Means we are going through a very long series of trials and the proportion of outcomes that may come from that trials. So it is between 0 and 1. So you know between 0 and 1 there are infinitely many numbers. Likewise, if I'm writing 0.00002, it is also between 0.1. So what are the chances of this number? So it is 2 upon 1, 2, 3, 4. Matlab, means that in 10,000 trials, this is 10,000 trials, my head, we are taking generally one example, or you can say in a rolling of a die, my number one of die came 2 times when I have rolled the die 10,000 times. That's the thing. When we generalize the probability, what it is? Proportion. This is a proportion. Occur of proportion of a single. That's clear. Today my speaker and all are
Mhm.
working.
Yeah,
So
it's
outcomes
very
that
clear.
never, yes, outcomes that never occur. So that's the thing. There's two things. So in cases, so case one, the outcomes mean I'll give you the outcomes that are impossible to occur. That are impossible to occur. That are impossible to occur, or you can say do not occur, has a probability 0. That is also called as impossible task. Impossible task, or you can say impossible event. Event generally word is used. Event matlab means that you are waiting for a specific task or event to come. Likewise, for example, getting 7, number 7 on the upper face, on the upper face of a die when it is rolled, 1 million times. That's the thing. 1 million times. So what will be the probability, say, to get 7 on the upper face? So how you in a die, you know that what are the numbers generally in a die? It starts from 1, 2, 3, 4, 5, 6. Correct? There are 6 faces and there are 6 digits on it. Yes or no? So is there 7 there? So what will be the probability of 7? So there is no 7, means it is impossible to occur. Let it may be millions of trials there. So the probability will remain 0. Is it clear?
Yeah.
Yes. Okay. Okay. Yes. That's the thing. Okay. So hand. Yes. An outcome that occurs. Okay. So that's the thing. So the outcome, and the second case is the outcome that is very that is very the outcome that is very sure to occur is very sure to occur, or you can say occurs every time, occurs always, or you can say occurs every time, has a probability 1, has a probability 1. How? I'll give you one example of this also. Have a probability 1, and is also called as sure outcome. Sure outcome. That was impossible outcome. This is sure outcome or sure event. Sure event. That is the thing. What is the example of this? That sunrises every day in sun rises in the morning. What is the probability that sun will rise in the morning? So it's always probability of sunrise is always 1, because how many days? For example, there are 1 million or 10 million trials, 10 million days we have noted. So there will be 10 million times the sun will come out. So this divided by the equal number, so the probability will be 1. Got that? Yes or no?
Yeah.
That's the thing. That was so simple. Just you need have a larger dimension of thinking. Okay. So an outcome that happens half the time in a very long series of trial. So there's different cases. So for example, there are different probabilities. It ranges from 0 to 1. So if some outcome comes in every second chance, chance has probability 0.5. 0.5 means, for example, 0.5 means for tossing of a coin is the best example. Tossing of a coin, what is the probability of head? Probability of head is 1 by 2, and probability of tail is also 1 by 2. That way. So that's the thing how you need to calculate the probability. Okay, now we look into this. Okay. So that's thing. The horizontal line represents the probability and proportion of heads in the simulation approach. This value as a number trials becomes larger. 5.1b. Oh, this is the example. Yeah. So see, as the number of trials here are becoming larger, what I'll do, I'll take this out of a code. So you can see when we have made tosses 10 only, so there was many variability in our data. But when we have increased our tosses trials, so you can see that the data further is coming very close to 0.5. So this is the calculated value as well as for suppose the observed value, and this is the calculated value. So there is no big difference when the trials are larger. So that's the thing. So law of large number. Next is the law in probability. That's law of large numbers. Law of large numbers. So the law of large numbers says that if we observe more and more trials of any random process, the proportion of time the specific outcome occurs approaches its probability. Approaches its probability. That's a very good. I've told you as, or you can say it can be also termed. That's the reason I'm copying this definition here, because we can write it in one more sense. So as I can state it as, here he has given the laws of large numbers that as there are many more trials, so the outcome, the proportion of times that a specific outcome approaches to its probability. For example, we have seen here only. See, there was very variability. When you will calculate the mean of it, it will be around here. It will be, in this case, it will be around 0.7 or 0.6. It is very far away from 0.5, because between 0.5 and 0.6 there are infinitely many numbers. It can come 0.5, 0, 0, 0, 0, 0, 0, 0, 1, 5.0000002. So there are many proportional based things here, and the difference is very large. But here when you calculate, it will be around 0.52 or 0.53 or 0.57 or 0.49 or 0.47, which is very close to 0.5, by the way. So when number of trials are large, the proportion means the calculated. What I need to say is that the calculated when trials are in large numbers, so you can say the calculated probability is approximately equal to the observed probability. Observed means what? Observed probability means we are doing a task and observing the probability of a specific outcome, and the calculated. What is the calculated one? We apply the formula. Probability of heads, the outcome in a coin is 1 upon 2, which is 0.5. And here what we do the experiment and calculate. Do the experiment. That's the reason I have told observed probability. Do the experiment and observe it. That's the thing. Is it clear, say? Both the definitions, definition that was given in the textbook, as well as a new definition that I have made easy and give it to you. So the proportion of times the specific outcome occurs approaches to its probability. Actually, probability means to its calculated, or you can say fixed probability. That's it. Okay. So the outcome probability gives us a language to describe the long-term regularity of a random process that is guaranteed by the law of large numbers. The outcome of a coin toss and the sex of the next baby born in a that's also a good question where probability is half. You need to determine the sex of the, what you'll say, the baby born. The baby born. So what is the total possibilities? Either a boy or a girl, correct? So I am
Yeah,
calculating the
50%.
yeah, very good, probability of boy. So it may happen that boy is 1 and the total number is 2, 0.5, and probability is girl also is, yes, in percentage also you can write it. 0.5 means 50%. This also means 50%. Yes.
Mm-hmm.
Good. Yeah. So the that thing. So is the result of a random sample or a random assignment. Even the insurance is based on the fact that deaths occur at random among many individuals, because men are more likely to die at a younger age than women. Yes, we see that. Insurance companies sometimes charge a man up to 3 times more for a life insurance policy than a woman of the same age. That is the thing. Okay. Now what's the next? Who drinks coffee? Okay, come on, read it and give me the answer. Come on, fast.
Mm-hmm.
Yeah.
The number B, no, since it's not exactly exact. Uh,
Okay.
I
According to
guess
the book of odds, the
yeah.
probability that a random selected US adult drinks coffee on a given day is 0.56. Okay, means the probability of the students drinking that are drinking coffee is 0.56. Okay, interpret this probability as a long run relative frequency. Okay, you have to interpret this probability as a run relative frequency, means that the students that are going to drink coffee, it will be 0.56. So how he has interpreted, we'll see. So if you take a very large random sample of US adults, about 56% of them will drink coffee that day. That's the thing. Just you have to interpret in the form of percentage, or you have to give a statement. For suppose they are planning for a, what you will say, an event. So how much number of cups must they prepare coffee, and how much number of cups they prepare tea. So in a very long conference, so you may tell that 56% of the total population or the people attending the conference will have coffee and the rest will have the tea. That's the thing. If there are two choices based on it, that's correct. So if a researcher randomly selects 100 US adults, will exactly 56 of them coffee that day? Explain your answer. See, in taking 100, they will be not be very close to 56. May not be very close to 56. Why? Because the sample size is very small. The sample that we are taking to experiment is very small. If it would be around 1,000 or 10,000, then you can say that 556 will 560 or 5,600 or 5,060,000 will drink coffee. If the sample is very large, it can be like that. The sample is large. That's the thing. Is it clear, Zaid, the answer?
Yeah.
Okay. Life insurance companies, casinos, and other who make important decisions based on probability. You know that financial analysts have the most value in banks and in insurance companies, in mutual funds, in share markets. Why? Because financial analytics guy, he does all the probability and statistical tasks on the shares, on the probability of a person debt and all. That's the thing. So there is a large value and large decision that is taken in the market based on the probabilitical concept, and everywhere you'll see probability is used. Generally we also in our daily lives use probability, means what are our chances of passing. So if you have studied very well, then you will say, Array, I have 99% chance of passing or getting this much or this much marks. So we generally speak in terms of probability, but we don't, what you will say, concentrate that we are speaking the terms of probability. Understood? That's the thing. So understanding randomness, the idea of probability seems straightforward. It answers the question, what would happen if we did this many times. Understanding random behavior is important for making decisions, especially when our data collection process includes random sampling or random assignment. But understanding randomness isn't always easy, as following activity illustrates. What's the activity? I will read this. I'll also read at my end. Okay. So what he is generally telling that you have to take a coin and you have to flip it 50 times in a row. Okay. And you have to note the longest run in that. Means what? For example, I have a coin. So I have tossed it first time, so it appears tails. Then the second time it appears heads. The third time it appears tails, heads, 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 then tails. Like this, you have to turn 50 times. Okay. There will be 50 different outcomes. There will be 50 different outcomes like this. So what you can see, what is the longest run of heads? So you can see in this, we have drawn the longest number of heads are 4. Correct. So but in when you will do draw next time, you will do, for example, heads, tails, heads, 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 heads. It may happen after a long time also, at the end also, that tails are very large. Tails. So what you have observed, that tails appeared, for example, 25 times. So the longest run of tails is 25. Your longest run of heads, it's 4. So depending on the different what you will say, the flipping, it depends that what are the longest number of run of tail, longest continuous runs of tails, and longest run of continuous heads. So that's the thing, and you have to plot it in dot plot and see what does randomness notes. That's the task. So that's the thing. So we'll read it here. The idea of probability is that randomness is predictable in the long run. So I have told you that when the trials are long, the trials are long. He's just trying to explain us randomness only till now, because randomness is very important. I've told you, randomness is the task there will be used multiple times, 90% of the times in statistics. So in long run, the outcome is predictable. The outcome is predictable. That is the thing. Understood? Okay, so unfortunately, our intuition about random behavior tries to tell us that randomness should also be predictable in the short run. When it isn't, means short run, it is not predictable. We look for some explanation other than chance variations. Suppose you toss a coin 6 times and get T, 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 T. Some people think that the next toss must be more likely to give a head. It's true that in the long run, heads will appear half the time. Yes, in this 6 times, it must happen that 3 must be tails and 3 must be head, as the probability of tails and heads are half when we have calculated it. But here, the next toss is more probably of head. Why? Because 6 times tails have occurred here. Okay. So it's true that in the long run, heads will appear half time. What is a myth is that future outcome must make up for an imbalance like 6 straight tails. Coins and dice have no memories, means it does not have memories. It is memoryless thing, that it will not remember that the previous time that I have tossed and I have given an outcome of tail, and now I have to give a head. It is memoryless. So a coin doesn't know that the first 6 outcomes were tails, and it can't try to get ahead on the next toss to even things out. So of course, things do even out in the long run. That's the law of large numbers in action. After 10,000 tosses, the result of the first 6 tosses don't matter. They are overwhelmed by the results of the next 9994 tosses. Is that clear? So when asked to predict the sex of a boy or a girl of the next 7 babies born in a local hospital, most people will guess something like BG, 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 GG. Few people would say GG, GG, G, B, 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 G. Because this sequence of outcome doesn't look random. In fact, these two sequences of births are equally likely. Runs consisting of several of the same outcome in a row are surprisingly common in random process. Many students are not aware of this fact when they imagine a sequence of 50 coin tosses in the investigation randomness act. Is there such a thing as not hand in basketball? Believe that runs must result for something other than just chance. So means he's trying to explain that the things just depend upon the chance purpose, and every time the coin is flipped, it is based on the chance. So if a basketball player makes several consecutive shots, both the fans and the teammates believe that she has a hot hand and is more likely to make the next shot. Several early studies of hot hand theory showed that runs of basketball made or missed are not more frequent in the basketball than would be expected if the results of each shot is unrelated to the outcomes of the player's previous shot. That's the thing. So that's all he has given, depending on the chances and randomness shots that the footballers generally think of. Okay, so what's this thing? So Pedro drives the same route to work on Monday through Friday. His route includes one traffic light. According to the local traffic department, there is a 55% probability that light will be red when Pedro reaches the light. Interpret the probability. So probability is a measure of how likely an outcome is to occur. Match one of the probability that follow with each state. Okay, first question we will do, first of all. Okay, so what Pedro drivers? First question. Drivers the same route to the work on Monday to Friday. His route includes one traffic light. Okay, Monday to Friday. First of all, there are 5 days. Pedro driver. Pedro driver. Pedro driver. So there are 5 days that is going Monday, Tuesday, Wednesday, Thursday and Friday. So what is the chances that he reaches, for example, for suppose he's a road and there is a signal for suppose. So he reaches here and the signal goes on red. So you have to stop here, for example. So what is the probability that he needs to stop? So it is 55%. 55%. So what is the imperative efficiency? 55% is around 0.55. So what 0.55 tells us? 55 upon 100. Yes or no? Right? When we interpret it. 55 upon 100 means in 100 trials, it may happen that 55 times he have stopped. 55 times he had stopped. But telling in a small sample size here in 100, it is very risky because it may not be exactly 55 times. It will be very larger or very greater, but there may be very large variability in the data. So you can say that 5,000 in how many zeros are there? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. You can say that in unit as 100,000, 10,000, lakh, 10 lakh. In 1 million
Remove a
times.
zero.
Yeah. So one
Remove a
more zero?
zero.
No. One more zero?
Just
No.
remove one. Yeah, just one more zero in the 5500.
3 zeros, na? 55,000 here. Okay. Yes. Okay. Correct. So that's the thing. So here in this, in 5,50,000 times. So here in 10 lakh times, 5,50,000 times, you will stop at the signal. So when the sample space is very large, you can give the outcomes, but 55% means the interpretation of the result is that more than half of the time he will stop at the signal, at the light. Okay. So probability, now in the second question, probability is a measure of how likely an outcome is to occur. Match one of the probabilities that follow which each statement. Be prepared to defend your answer. Okay, come on, sir. Match it with ABCD and just give me a minute, okay? Okay. So have you matched it? For example, that this outcome is impossible. It can never occur. So what will be the probability? Say, you know that.
That it's impossible, zero.
Very good. I'll take this on our board.
Zero's A.
Yeah, correct.
0.01, 0.3 is C.
The 0 is for this, and this
Yeah.
outcome is certain. It will occur in every trial. So what will be this answer for this B1? What will be the answer? So what will be the probability? It is certain to occur. Certain means it will occur on every trial. So what will be the probability?
1.
1. Very good. Certain means every time it will occur, correct. This outcome is very unlikely, but it will occur once in a while in a long
0.3
sequence
and
of
0.01.
0.001. Very good. Correct. Why you have to tell your defend your answer also.
And
So as
0.3. And
this
0.3.
okay 0.3. This outcome will occur more often than not. Huh, will occur more often. More
And
often
with
means you have to with this
0.99.
zero. No, more often means 0.6.
No,
When you compare 0.6
more
and
often.
0.4, so in this comparison, see both the addition. See, for example, happening, it is happening and it's not happening. For example, I'll explain you happening and not happening. What is the difference? For example, this
It's
is the
also
probability of head.
0.99.
Yes, zero. This is the probability of head. So this becomes the probability of tail. So what he's telling, it is more often to occur than not. So what will the probability? More
Mm-hmm.
often is 0.6. Is it correct? Good? Or it can be 0.99 also.
Mm-hmm.
You can tell that it is very much often. Very much. 0.99 means it is approximately 1. It is very much often. Okay. So 0.6
Mm-hmm.
is the best answer because it is the according to the question, it is the best fit for it. Okay. Then it is the next question.
Mm-hmm.
Like, come on, tell me. A husband and wife decide to have children until they have at least one child of each sex. The couple had 7 girls in a row. Their doctor assures them that they are much more likely to have a boy next. Explain why the doctor is wrong. Now you have to explain because the what you'll
There's a
say because
50% chance.
yes, there is a
It's
50% chance.
a
Correct.
chance event.
Correct. So there is no memory.
You
What
cannot
you'll
be
say.
sure if
Correct.
it's
That's correct.
gonna be a boy or a girl.
Correct. Yes, that's good say. Now on to the next topic. That's simulation. Next topic. That's also very much interesting, by the way.
Mm-hmm.
That's simulation. So simulation, what simulation? We can model random behavior and estimates probabilities with a simulation. What he's telling? We can model random behavior. Model means what? What is the modeling? We can take the random behavior onto the paper or onto the visualization thing. That's called model random behavior and estimates probabilities. Estimate means calculate or comment on. Estimation, prediction. Okay, with a simulation. So what is a simulation? Simulation imitates a random process in such a way that simulated outcomes are consistent with real world outcomes. You have
Uh-huh. Yeah.
seen simulators are there, plane simulators, when a person is becoming a pilot. So he is not directly given the plane into the hands to fly over, but he is given a simulator which gives a real world example like a plane that he is driving a plane, by the way, in his hand. And he practice a lot on that simulator planes. And then a real world plane is given into his hand to fly it. Yes or no? So that's mainly simulations. I'll take this one and we'll write our definition also. Simulation, what simulation? A simulation imitates a random process, imitates. What is the meaning of imitate? We'll search on it. Imitate meaning, the perfect meaning of imitate. Imitate, to behave in a similar way, to behave in a similar way to someone or something else, or to copy the speech or behavior. Imitate means it will behave in a similar way. Simulation imitates a random process in such a way that simulated outcomes are consistent with the real world example. Means it copies the real world examples. Means in a simulation, when we are doing simulation, the outcome of simulation, the outcomes are similar to real world experiment. Got that? That means I'm simulated. That means he's flying a plane. So all the hurdles that all challenges or the barriers that you face while flying a plane, he will face all the hurdles, the challenges, and the barriers in the simulator also. Simulator plane also. That's called simulation, by the way. Exact copy of the real world task or the real world example is called as simulation. Got that? The simple definition. Exact copy. I'll write it down as exact copy. Exact copy of the real world example is called as simulator, or you can say simulation. Is it clear, Zaid? So that's he has given different example there. You have already seen some experience with simulations in a hiring discrimination. It just won't fly. Activity in chapter 1. You drew breadths of slips of paper to copy a randomly lottery. Imitate means copy, randomly lottery, to choose which pilot would become captain. So the analyzing the caffeine experiment asks you to shuffle a deal piles of cards to mimic the random assignment of subject of the treat. The 1 in 6 wings game that opened this chapter had you roll a die several times to simulate buying 20-ounce soda and looking under the cap. The goal in each of these cases was to use simulations to answer a question of interest about some random process. Different random devices were used to perform the simulation. Beads, slips means what? We are generally simulating an experiment by using a die, by predicting it. Is it clear? That's the thing. So the simulation process describe how to use a random process. Means simulation, what does simulation do? It describes a random process to perform one trial of the simulation. Tell what you will record at the end of each trial. Simulation is generally a thing that you are performing a random process of noting things at the end of the each trial. But perform many trials of the simulation, use the result of simulation to answer the question of interest. So by using the simulation, you can answer the things. Means you just copy. For example, you remember that that 1 in 6 cap, 3 4 5 6, 1 2 3 4. Sorry, I'll not write inside it. That were two things here. Please try again, please try again, please try again, please try again, please try again. And there was in a you are winner, you are winner. So 1 in 6, there was a cap which had you are winner, 1 in 6. Correct? We didn't use in the experiment, that when you remember, we didn't use these caps. We use a die. We use a die. And we saw that how many times the number 6 comes there. That many times this will come there. Yes or no? So what did we do? This task that we need to do on the soda bottles, we did on a die. Soda bottle, we did on a die. So this task we have simulated the soda bottle to a die. Is it simulation clear? Yes or no, Zain? Yeah, that was the thing.
Yeah.
So that's generally simulation and task. So here he has given the explanation of all that, and he has plotted the dot plot. So by the way, we'll look on to this tomorrow. Is it clear? Okay. Have you given your test? Just
No.
complete the test by this weekend, or this weekend, Saturday or Sunday. So I'll forward you the third test also based on chapter 3. And we need to practice some more sums based on chapter 4 and chapter 5, inshallah. So we'll practice and then I'll give you a test based on. Is it clear? Because we have just seen theory of it. We have not seen sums based on chapter 4. If possible, I'll first take chapter 3 sums also in a couple of class. Chapter 3 in a couple of class, chapter 4 in a couple of class, and then I'll give you test on both those. But you can give the test based on chapter 4 now. Is it clear? So your first goal should be complete the chapter test number 2 based on chapter 2. Is it clear? So study hard and give that test based on Saturday or Sunday. Okay?
Yeah.
Keep care. Okay? Assalamu alaikum.
Walaikum salam.